position of the particle x at some time t. So that is x equal to a sin omega t plus phi 0. And then, like I mentioned earlier, it's that even if you add 2 pi to this bracket, even if you would add 2 pi to this bracket, that is you get this, still the value of x will remain same because sine gets repeated if you add 2 pi to this angle. So we are noticing here that the position at time t, that is x, is in fact same as the position at time t plus 2 pi by omega. Do you understand what I am saying? Position at time t is same as the position at time t plus 2 pi by omega. Yes or no? That clear? Because the value of x is same. Again, the x here and the x here both are equal, right? That is when the time is t and when the time is t plus 2 pi by omega. Okay, how many of you got it? I want the response. Okay, this is a critical thing of for this chapter. What we are doing is we are comparing this place. Here there is t and here there is t plus 2 pi by omega. So when the time is t and when the time is t plus 2 pi by omega, the position is the same, x. There is no change, right? Okay? Right? So just like this, if you would add one more 2 pi, so instead of 2 pi, if you add one more time 2 pi, then once again the position will become same. So that means this is same as the position at time, how much? Instead of if you add one more 2 pi here, you get t plus 4 pi by omega. Did you understand this? Just add 2 pi here, so you get 2 pi plus added over here, so it will become 4 pi by omega. Okay? Right. So now, this is where enters time period into this picture. Let's see how. Think of Earth. Okay, let's say that at this moment Earth is such that this is Surendranagar. Okay, this is where you are standing. Okay, after 24 hours, this will go around, come back to the same point, same position. After how much time? So let's say right now time is t. Then after t plus 24 hours, you would have same position, and then t plus 48 hours, you would have same position, and then t plus 72 hours, you would have same position. Do you understand all this? It would be in the same position, yes or no, at this time, this time, this time, and this time. Yes or no? Right. So what does that mean? If in some periodic motion, see this is a periodic motion, rotation of Earth is periodic motion with time period 24 hours. So what we are seeing is that every 24 hours it gets repeated. Every 24 hours the whole picture, the whole cycle gets repeated. Is this fine? Okay? Compare that with this. Position at time t, then position at time t plus 2 pi by omega, and then position at time t plus 4 pi by omega. Every time, do you realize that we are having a gap of time? How much gap of time? How much interval of time? 2 pi by omega, and everything gets repeated, correct? Did you understand what I am saying? After a gap of 2 pi by omega, it's getting repeated. Did you understand? Just like here, it's getting repeated after a time of 24 hours. Plus 24, plus 24, plus 24. Like that. Plus 2 pi by omega, plus 2 pi by omega, plus 2 pi by omega, like that. Okay, continue. So, what does this mean? What does this mean? Just like here, 24 hours is called the what? What is this called? 24 hours is called? What is 24 hours called for Earth? Time period of rotation. Very good. This is the time period of its rotation. Clear? This is the time period of rotation. rotation. That means when it's rotating, after 24 hours, everything will be back to what it was, right? So just like that here, for this particular SHM, what is 2 pi by omega? It is the time after which everything gets repeated. So 2 pi by omega shall be called what? Time period. Did you understand this? Yes or no? Time period. Okay? So now that means we have found meaning. We have got or associated meaning with three constants that we are writing in this equation. Okay? So let's summarize what we have learned so far. Okay? Especially about the maths. So for a particle doing SHM on x-axis with mean position at origin, position at time t equal to t is given by which equation? By the equation x equal to a sine omega t plus phi 0, right? So this x is telling you about the x coordinate. Let's also draw a diagram here. So what do we mean? We are saying that suppose mean position is here at the origin, right? So these are the endpoints as usual. So the particle is doing SHM on this x-axis, right? Okay, it might be moving here and here and here and here like that. Okay, so what do all these constants indicate? X of course indicates x coordinate. There is no doubt about that. A for amplitude of SHM. Again, amplitude means the maximum displacement that this particle goes from the mean position. Okay. Then, what does omega indicate? We have just learned omega, right? I have not told you the name. Now it's time to tell you the name. Omega is called angular frequency. Omega is called angular frequency, right? Okay, and why do we call it angular frequency? Right? That reason you will get very, very soon once we make list of the terms. I'll go to that. T for, okay, sorry, we don't have T. Small t for time, right? And phi 0 for what? Initial phase, right? Okay, so this is somehow related to time period, right? That tells you in how much time, the SHM or one oscillation is completed, right? T for time, of course, an initial phase tells you where it starts from. Okay, now there was a question earlier. What is the difference between oscillation and oscillatory motion? Right? I'm going to answer that question now. Right? What is the difference between oscillation and oscillatory motion? Okay. Right? Why am I answering it now? Because it's related with time period. See, suppose some object, okay, starts its SHM from here, let's say. Okay, from the positive endpoint. Okay, that is from x equal to plus a. Now it will start moving. Let's say it goes here, here, and comes back. Do you realize E to M to E dash to M to E. This is one cycle. You agree with me? This is one cycle of motion. Yes or no? Okay, because what will happen after this? E to M to E dash to M to E. After this, the same thing is repeated, isn't it? So this is what is one cycle, right? So this is the motion. This will take how much time? Will take time period. Do you understand this? This will take how much time? It will take a time period. Did you get that? That this will take one time period because that's one cycle. Clear or not clear? Okay? Well, this thing is what is called one oscillation. Okay? This thing is what is called one oscillation. Right? We generally do not use the word cycle, but I still say that cycle is a very easy way to understand what's going on. A proper word for that is one oscillation, because oscillation means it's going back and forth, right? So if you talk about motion, there is no difference between oscillatory motion and oscillation, but still the word one oscillation is very specific. Did you understand the meaning of one oscillation? Right? Okay? But you see, I don't want anyone to get into the wrong thinking that oscillation or one oscillation can only start at end point. No. Let's take another example of what is one oscillation. Suppose you start watching the particle when the particle is here, let's say, right? Before that it was moving, but we don't care, we didn't see it. You understood? We start observing, let's say, when the particle is here, right? So M. From there, let's say right now it's going towards the right hand side. So it goes from M to E. Then from E it will have to come back to M. Is this one oscillation? Yes or no? Is this one oscillation? Would you call this one oscillation? Would you call this one oscillation? No, this is not one oscillation, my friend. One oscillation would mean a complete cycle is repeated. So for example, here it's going from M to E to M. Okay, you might be thinking, sir, it's back in M. Yes, I agree, it's back to the point M, mean position. But after that, what will it do? Will it repeat what it just did, or will it do something else? After going from M to E to M, where will it go? Will it go back to E, or will it go to E dash? Will it go back to E, or will it go to E dash? Very good, it will go to E dash. So do you realize that this is different? Did this same pattern get repeated here? No, right? It's not going back to it. Now it will go from here to E dash. Then from E dash it will go back to it. This is one oscillation. Do you realize that this is one oscillation? Because if you think what's going to happen after this? M to E to M to E dash to M. Okay, after that what will happen? Where will it go? From E dash to M, then it will go from M to E. Do you realize that we are back here? Do you realize we are back here? No, Pala. Okay, so one thing is clear, that oscillation will start and get completed at the same point. What I mean to say is, if an oscillation starts at E, it will definitely finish at E, right? Okay, if oscillation will start at E, it will definitely finish at E. But that does not mean that every time here it comes to M, it is one oscillation. No, because not only the position, see, the key thing is position is repeated, fine, position is repeated, but the direction is not repeated. What I mean to say is, first it goes from M to E to M, okay, then it will not go back to the right side, it will go towards the left side, so it's doing something new. You understand what I am saying? M to E to M, fine, but then it's not going back to E, it's going to E dash, which is something new, so that's not repeating. Is that clear? So E dash, and then when it comes to M, one oscillation is completed. Completely clear all this? Okay, right? So this is the equation. Why do we call it angular frequency? Let's go over to that. Right. So we have already derived that omega is equal to, we have derived that T is equal to 2 pi by omega, isn't it? We have derived that time period, we have written that the time period is 2 pi by omega, correct? That's what I had explained before a while. Okay? Yes or no? So this is again a very important formula of SHA, right? Same can be said about this also, right? So T is 2 pi by omega. If you want, you can just play with it a little bit. Okay, obvious step. What is 1 upon T? What is 1 upon T? Do you remember what is 1 upon T? Oscillatory motion means going back and forth. I had explained that at the first line of this chapter, Gracie. Come on. First line of the chapter was oscillatory motion means going back and forth. So this is frequency, yes. So if I use it here, I will get a relation omega equal to 2 pi f. Understood? Omega equal to 2 pi f. Right? So this is another important relation for SHA. Now this relation itself is the reason why it's called angular frequency. Okay, because it has something to do with this angle, right? It has something to do with the angle and frequency also, right? Okay, so that's the reason why it's called angular frequency. Of course, its unit, listen to this carefully, because this is going to be an angle, right? Its unit will be radian per second. Okay, here this is an angle, so if you do a bit of dimensional analysis, you'll realize that this whole thing is an angle. So omega's unit is radian per second. Okay, fine. So we have got these relations between T and omega and f, right? So if someone would ask me, what role does omega play? What role does omega play? Then I can say that omega is angular frequency, right? Which is what connects the time period, okay, with the equation. Phi 0 tells you where it starts from. Amplitude A tells you how far it goes from mean position, right? Okay, and omega tells you about time period, that is how quickly the motion will get repeated, right? Everything in this equation clear? Right. One little note. Can we write cos instead of sine? Yes. Yes, no problem. Okay, even if you write cos instead of sine, still it's going to be SHM. Right? Still it's going to be SHM. Right? So when you solve a question, listen to this advice carefully. When you are trying to solve a question, okay, and you are not given an equation, then you have freedom. You can either choose a sin omega t plus phi 0, or you can choose a cos omega t plus phi 0. There is not a single question that you can solve with cos but not with sine. You understand what I am saying? Or vice versa. Is it clear or not clear? You can either use sine or cos. There is no such restriction. Okay, there is no such restriction. But yes, you cannot mix and match. That is, if you start solving a question by sine, then halfway through it you can't make it cos. Okay, that would be cheating. So be careful with that. Well, so those are the important mathematical terms that we have learned about SHM so far. Right. Okay. Now, let's see position versus time graph for particle in SHM. Okay, so let's draw a position versus time graph for particle in SHM. Right. First of all, let me write the equation x equal to a sin omega t plus phi 0. Now you see, if there are so many unknowns here, it's not very easy to draw the graph, right? I'm not saying it's impossible, okay, but it's not easy to draw. So what we would do is, we will just assume a few values. For example, we will draw first of all for phi 0 equal to 0. Clear? We will draw the graph first of all for phi 0 equal to 0. Right? Then we will try for other values also. Okay, stepwise. Right? So now the equation would be what? X equal to a sin omega. Right? Now as I draw the graph, I will also try to make you imagine where is the particle at that particular time. Okay, so two things going on simultaneously. Right? Hopefully the board provides enough space. So first picture, okay, let's draw a picture first. Picture at t equal to 0. The first picture we are going to draw at t equal to 0. So what we should do? At t equal to 0, right? We should put x. Okay, put 0 here, put 0 here. Sin 0. X equal to a sin 0 is 0. Okay, I don't think I need to worry too much about that now. So let me draw it. So where's the particle? X equal to 0 means at mean position. Is it clear? I am indicating particle by this hollow large circle. Okay? This is x equal to plus a, this is x equal to minus a, and this is x equal to 0. Right? So here is the particle. Is it clear? Right? Okay. Then let's allow some time to pass. Okay, let's allow some time to pass. For example, a time of capital T by 4. Okay, that's interesting. Why capital T by 4? Capital T for what? Time period. By 4 means it should finish 1/4 of the oscillation. So from here, it's going to go over here. Right now I know that, but let's prove it. X equal to a sin omega capital T by 4. Okay, I just put the value of t over here. Right? I hope you are seeing that. So let's simplify this a little bit. A sin omega is 2 pi by capital T. Okay or not okay? Is this clear? This step, everyone, is it clear? So tt cancelled and 2 is cancelled with 4. So this will become a sine pi by 2. Pi by 2 means how many degrees, everyone? Pi by 2 how many degrees? Hurry up. Pi by 2 is how many degrees? 90. Very good. So sine pi by 2 will be 1. Okay, so this is A. Like I said, the particle will be here. So let's draw a new diagram. So what has happened? Okay, I suggest that everyone draws it. That way you will be able to imagine what is going on. So I said that when t is t by 4 and t is capital T by 4, x is equal to a. That means from here the particle started moving and it went here. Okay? Now here is the part. Did you understand the second diagram? Did you understand the second diagram? Okay. Right? This is still not the graph, everyone. Remember, I am just taking a few simple steps so that we can draw the graph easily. Right? Like this. If you would take t equal to t by 2, okay? If you would take t equal to capital T by 2, so that means 2 times 1/4. You know, you can understand it like this also. 2 times 1/4 oscillation. So you can use a little bit of intuition, but be warned. Okay, in this chapter, cross multiplication and such things don't work often. So be very careful. So I can still tell you where it would be by imagination, but let's use some maths. X equal to a sine omega into small t. So omega is 2 pi by capital T, and now into small t is t by 2. Again, go back to this equation that we are using. So what's cancelled here? T cancelled, 2 cancelled. So this is a sine pi. What is sine pi? What is sine pi, everyone? If you cannot recollect what is sine pi, first of all convert pi to degree. Pi radian, how many degrees? Pi radian, how many degrees? 180 degrees. Very good. Sine 180 degrees. Sine 180 degrees. Okay, some of you are making mistakes. Sine 180 degrees. What's the problem? See, unit circle is your friend. Hopefully you remember that sine means y coordinate, and 180 degree will come from here to here, right? This is 180 degree point. So at this point, what are the coordinates? X coordinate -1, y coordinate 0, and sine is y coordinate. So sine pi or sine 180 degrees will be 0. Clear or not clear? Clear or not clear? मैथ्स वाला अभी भूल करसे तो चालसे. Okay, sine 180 degrees is 0. Sine pi is 0. So x equal to 0. Okay, let's draw a diagram now. Let's draw a diagram. I am erasing this circle. Okay, we don't need it. That was for explaining the maths. Well, so here, mean position, end positions, right. So x is 0. That means particle is here. Can you imagine already how particle is moving? At t equal to 0, it started here. Then it went towards the right side, t equal to t by 4. Then it came back, t equal to t by 2. Is that clear? Or to t by 4. Understood the journey so far? Went like this and back. Yes or no? Okay. Fine, let's proceed. What will happen now? Can you tell me at t equal to 3t by 4, where do you expect? Okay, let's see. Where do you expect the particle to be? Based on whatever we have discussed so far. Come on, everyone. Where do you expect the particle will be? थोड़ा intuition use करो, no problem. Yes, it will be at x equal to minus a, or you could say it will be at the point E dash. Okay. Now let me prove it also. Right? We don't want to just use intuition. Let's prove it. So x equal to a sine omega, that is 2 pi by capital T, into small t is 3t by 4. Okay, t cancelled, 2 cancelled here, so this is a sine 3 pi by 2. Okay, I don't think math students will have any problem. Sine 3 pi by 2 is minus 1. Okay, for others, in case you have forgotten it, right, you could use unit circle. Okay, I'll just do it here. See, 3 pi by 2 means 270 degree. That's this point, isn't it? So for this point, what are the coordinates? X coordinate 0, y coordinate minus 1, isn't it? Okay, so that means sine value is minus 1. Okay, I hope that is clear to everybody. Well, so that's the third thing. Okay, now let's draw it on a diagram like this. So here is E dash. This is where the particle will be. Okay, at x equal to minus a. Fine. And now the last one. What will be the last one? When time is 4t by 4. See, 1t 0, 1t by 4, 2t by 4, 3t by 4, and 4t by 4 means capital T. Okay. So here the particle would be at, let's do the maths again, a sine. What do we have? Omega 2 pi by capital T into small t is t. T cancel. Sine 2 pi means sine 360 degree is once again 0. Okay. So x is equal to 0. Means the particle has come back to the mean position. Here. So what's the journey like? Have a look again. M to E, t by 4. Okay, then more t by 4, e to m. So time is now t by 2, half oscillation. Then from m to e dash, now time is 3t by 4. And then from here to here. Did you understand what I have drawn? Did you understand this? Okay. Right? You can hear me. Fine. So that's what it is. Now time to draw the graph. Hopefully you have noted everything. Okay, we will use this. Have you noted everything? Raise your hand if you have. They have to erase, wipe up the whole thing. Okay, everything from here. Right. Now we will draw the graph. Okay. Now we will draw the graph. You mark these values carefully. Okay. Math students are not going to find too much of a problem, or probably you just remember it based on your trigonometry lessons that you have in your 11th standard. So here's the graph. Find it. Okay, so this is x, means position. Okay, and let's say here are 4 equally distributed intervals of time. This is t by 4. This is t by 2, that is 2t by 4. This is 3t by 4, and this is 4t by 4, that is t. Okay, then let me just draw it a little bit more also. Okay, this is 6t by 4. Again, see, 1t by 4, 2t by 4, 3t by 4, 4t by 4, 5t by 4, 6t by 4. Okay, and so on. Let's go. So at start, at t equal to 0, what was the position? It was 0, wasn't it? Okay. Then at t equal to t by 4, the position was x equal to plus a. Do you remember that? Or do you have it in your notes? Plus a. Then at t by 2, the position was 0 again. Then at 3t by 4 the position was minus a, and then at t it was 0. Okay, let's draw this so far. So from here to here, then here to here to here, but not in straight line, remember. Okay, here the velocity doesn't remain constant. So it will be like the graph of sine, math students. I'm sure you are completely familiar with this. Okay? Understood the graph so far? Suddenly you realize that my drawing is not so bad. Okay. What happens then? This is one oscillation, or this is one time period, and then whatever happens after this will just get repeated. So for example, if you just draw one imaginary line here just to see what's going on, after this it's just the same. So from here to here, and then here, and then here, and like that. Understood? Is it clear or not clear? So this is one time period. Okay, this is the second time period. Then there will be third, fourth, and so on. Okay. Graph clear to you? Is graph important? Sure. Very important. Okay. This is the amplitude. Just one clarification. I know sometimes students get confused, right? So before that confusion creeps in, let me clarify. Here is the particle moving in wave-like shape. Here is the particle moving in wave-like path. Yes or no? Is the particle moving in wave-like path? No, 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 no. No, the particle is moving in straight line. Did you forget those points? What was the particle doing? Particle started from here, then went here, and back, isn't it? Particle is moving in straight line. Is it clear? Okay, particle is not moving in a wave-like path. Fine. Yes, if you take cos, then the graph will be like cos. But everything really depends on the value of phi 0. Okay, I just want you to write this over here at the top of this graph. That we have drawn this graph for phi 0 equal to 0. We have drawn this graph for phi 0 equal to 0. Okay? Now, based on this graph, let me just ask you some simple questions. Then we will try it for other value of phi 0. Okay? Right. So, a very basic question. How much time does particle take to go from x equal to minus a to x equal to plus a? That is to go from one extreme position to the opposite extreme position. How much time does it take? To go from one extreme position to the opposite extreme position. Read. Okay, look at the graph carefully. Those who have already answered. Okay, Ria, let me just repeat it quickly what you are saying. See, the particle is here, it's moving as if there was a spring attached. If you take a spring and you pull this, how will that move? Ria, I am talking to you. If you take a spring and attach a block and then you pull it, how will the spring move? Will the spring move in a wave, or will that mass move go back and forth, back and forth, back and forth on a straight line? That's what I was asking you. right? How does that mass move? Does it move like a wave or does it move on a straight line? Okay, fine, yeah. So the correct answer to this question is T by 2. The correct answer to this question is T by 2, not T. Okay, many of you gave T by 2 answer, very good. Okay, others, let me just explain. Have a look here. Question is how much time does it take to go from minus A to plus A? Okay, where is minus A? Here. To plus A. Here. Is this fine? So what's this time? 3t by 4. What's this time? 5t by 4. So how much time does that take to go from here to there? Answer is 5t by 4 minus 3t by 4. Is that clear or not clear? That is nothing but 2t by 4 or t by 2. Got it? Got it or not? Okay. Some of you would have done using intuition also, no problem. There is no need to do maths every time, right? The answer is right. It will take t by 2. You could also think how much time does it take to go from plus A to minus A. Then also you will see that easily. From here to here, t by 2. Okay? Well, now let me change this question a little bit. How much time does it take to go from? Okay, fine. Let's do it separate. I'm changing it. Sorry, just one. Here. Yeah. How much time does it take to go from x equal to 0 to x equal to a by 2? Come on. How much time will it take to go from x equal to 0 to x equal to a by 2? That is from 0 to a by 2, somewhere here. T by 4, are you sure, Raj? आंसर क्या आपको जो खतरनाक T by 4 पर तो A ऊपर पहुंची. How can it be here at A by 2 also, right? Okay, many of you have given answer T by 8. I like that answer, but that answer is not correct. Okay, let's see why. Okay, that's what I was telling you. Cross multiplication doesn't really work in this chapter, so be careful. Maths is your friend, whether you believe it or not. Okay, let's begin. See, this was at time t equal to 0 based on our graph. Yes or no? Okay, this was at t equal to 0. Fine. Now let's think about this, but here we need the time, so we will use equation x equal to a by 2 sine omega t. Remember, we are doing this right now for case phi 0 equal to 0. Is this step clear? Oh, sorry. X equal to a sine omega t and x is a by 2. Is this step clear now? I am just using the equation that we know. Which equation do we know? We know this equation, x equal to a sine omega t plus phi 0. What is x value? A by 2. Very good. A is a, omega t, and phi 0 is 0. So that's how we got this equation. Now let's cancel things. So 1 by 2 equal to sine omega t. Okay, and instead of omega, let me write. Okay, fine, never mind. This way it will be easy for you. Yeah. So half is sine omega t. So what is omega t? Which angle sine gives you half? Which angle sine is half? 0, 30, 45, 60, 90, 170, 200. Which one? Which angle sine gives you half? Trigonometry મારી નાખજો, value યાદ રાખીને આવજો કાલે. Which angle sine is half? 30 degree. Very good. So 30 degree in radian is pi by 6. Okay, 30 degree in radian is pi by 6. Clear? Okay, now we want to find t. What's omega? 2 pi by capital T. Solve this equation, very easy to do, isn't it? Solve this equation. And the final answer will be t equal to, surprise, surprise, what do you get? Come on. Do you get t by 8? What do you get? T by 12, very good. So, even though, listen to this carefully, even though this displacement is half of this one, a by 2 a by 2 a, but still the time is not half. Did you realize? The time is only t by 12, means 1/3. Okay? Okay or not okay? Displacement half, agreed, but time not half. That's because the speed is varying or changing. Okay, the speed is not constant. This is happening because the speed is changing. I'm sure you can see that by the slope of this graph also. Do you remember? Slope of xt graph gives you velocity. Okay, so keep this in mind. We will continue the next time. Okay, make sure you remember all this, right? The equations that we have learned, the meaning, the use of all those terms of phi, 0 and omega and a, right? Okay, next time we will draw the graph for other values of phi 0. What happens if phi 0 is not 0? What if it's something else? Okay, goodbye.